Today, we're going to focus on trigonometric functions. So we're going to be speaking about graphs, transformations, period, amplitude, and exam interpretation. So we're going to look at sine, cosine, and tangent, right? So we know that a trigonometric function, so a sine is more like in this oscillation. Then a cosine is more like something like this. Going on. Maybe let me just do it. It's more like you start from here, like this. Something like this. This is the cosine. Then we're gonna look at tangents. So tangents, they're a bit should be something like this, something like this. I'm not sure, but we're gonna cover it. But let's leave the okay. I think let me start again. Good day, everyone. Today we're gonna be focusing on Unit 5, trigonometric functions. We're gonna cover graphs, transformations, period, amplitude, and exam interpretation. So we're gonna look into sine, cosine, and tangent. So this is what we are basically gonna be focusing on. So when we mean of transformation, we mean like changing the nature of that graph, the period, the amplitude. Let's say we are focusing, let's say a sine wave. The amplitude is the height, and the period is the number of degrees it takes to make a full complete cycle. So in this case, it's normal 360 degrees. So amplitude is normally an A. So for a normal one, the amplitude is usually 1. Then on the bottom it's -1. So this is some of the things they're going to be looking into. So we are focusing on grade 12 mathematics under the CAPS syllabus. So let's move on. So learning map. So by the end of Unit 5, learners should interpret, sketch, transformed trigonometric graphs. So the unit focus is generally to recognize basic sine, cosine, and tangent graphs, and explain amplitude, range, period, and asymptotes, right? And apply transformation controlled by A, B, Q, P, and Q. So we're gonna explain this. So basically, when we talk of A, we are talking of amplitude, right? Amplitude, which is the height of the graph. So using this sine graph, I've already demonstrated more like this. So the amplitude, let's say we are saying y is equals to sine x. So the height will be 1 and on below -1, right? So that is the A, right? Then the P. So let's say we say y is equals to sine x plus 1. Not plus 1, we can say, remember they work in degrees, so we can say plus 60 degrees, for example. So it means from here to here it's 180, right? From here to here, so which means in the middle is 270, in the middle it's 90. So for simplicity's sake, so that we don't confuse you, let's say y is equals to x plus 9. So let me change the color here. It means the graph will shift, if I'm not mistaken, it will shift by 90 degrees, which means it will start here. So it will be more like this. Remember, it's not drawn to scale. More like this. So it will now end at 450. Something like this. So it means it has shifted by 90 degrees. By 90 degrees. Right? Then the other part, if we say y, y is equals to sine x, right, plus 1. It means we are shifting it up by 1. So in this case, it's not moving. It's still on the same level. It's still starting from here, but we are moving it up. So it means instead of 0 being the median line, it will be 1. So let's say here is 2. Let's just extend it. Let's say here is 2. So it means it will be doing like this. Something like this. So this will be the new way it will end. So it just shifted up by 1. So it's pretty much similar to what we have done in the previous section, unit where we were dealing with transformation of quadratic line graphs and stuff like that. So it's pretty much the same thing. So this one controls the y shift. So y, which means up or down. Then this one controls the x horizontal, which is x, which is y, up and down. Then this one, it controls the what we call the when a normal graph, right, it completes a cycle in 360. So this will be like 0, 90, 180, 270, 360. So this is the normal for y. Y equals to sine x. So when you say y is equals to sine 2x, it means now, because the x is equals to 360 degrees, right? So if we now say 2x, it means 2x will be equal to 360, which means we divide by 2 both sides to get 180. So it means our cycle will be ending in 180. So it will follow that route. So it means it will be more like this. I'm just trying to. You can see that's more like it. So it will be the same for the cosine and and also for the tangent one, but remember for the tangent, the amplitude, it does not have an amplitude, doesn't